In this lesson, we'll talk about sequences, and let's start by seeing the difference between discrete and continuous data. Here, if we talk about a car traveling 30 miles per hour, after each hour it'll have gone 30 more miles. And over here we can look at this example. If you go to an amusement park and every time you go to a new ride there's 30 more people in the line. So now line 0, 0, well, we wouldn't really use this, but I'm just going to make it look like that, and just to compare. So here we have ride number 1 has 30 people, ride number 2 had 60 people, ride number 3 had 90 people in line. And these tables look the same, but are they really the same? And this is the difference between continuous and discrete data. So here we have I'm just going to plot the points in the table, and we know that the car is, after 1.5 hours, it's gone 45 miles. After 1 hour and 1 minute, it's gone some distance. It's not going to just be at these locations. It's continuous. Over time, the car's distance is continuous, or position. But if we look over here, and we plot these points, we wouldn't connect the points because there's no 1.5 lines. This is the line for each ride, so we don't say here's 1.5 rides or 1.1 rides and at the amusement park. So that's the difference between continuous and discrete data. When we talk about sequences, it'll be discrete. We're not going to, if we graph a sequence, we're not going to connect the points. We could say there's an equation of the distance of the car, and over here we can say P sub L equals 30L. Where n is natural number, meaning 1, 2, 3, 4, 5. Well, I guess I should say n is a integer, because I included 0, so I'll say n is an integer and n is greater than or equal to 0. Over here we can say that t is a real number. So with continuous data we have t being a real number, having all the decimals and fractions. Here I shouldn't say n, it should be L. So L is a positive integer including 0, and that just means we're not including fractions for values of L. Okay, so all you need to know from this is what discrete means and how to graph discrete numbers. We don't have to be concerned with this too much. All right, so with sequences, there are some formulas, but if you only understand sequences through formulas, it can be pretty confusing. So let's look at a graph. Look at graphically, numerically, algebraically, or analytically. And it's always helpful to start with the table. So we'll have n, a, n. And a lot of sequence questions can just be answered with a table. You don't even need the equation. So let's look at the pattern here. To get from 3 to -6, we could subtract 9, but we need to look at something that's going to work on all of them. So if I multiply by 2, or times -2, multiply times -2, -6 times -2 is 12, 12 times -2 is -24, and then it does ask for the next 4 terms. So then we just keep on multiplying by -2, and we would get 48, -96, 192, -384. So we answered the question just with a table, and we identified the pattern. Analytically, let's look at, we have two ways of writing, representing the sequence analytically, and one is a recursive formula where we have to say what the first term is, and then we describe how to get to the next term. And in this problem, we're going to we know that we just multiply everything by -2, so we can say it's -2 a n minus 1. Now this will require some effort to understand the difference between a subscript and an exponent or superscript. And what we're saying here is, if this is a2, then this is going to be a1. So it's the previous term. And this is saying that if you started with a1 to get to a2, you multiply the previous by -2. This says multiply the previous term by -2 to get to the next term. So we have recursive, and then we have explicit, and it's also called general form. It's also called nth term. So there's another confusing part about sequences is that there's a lot of vocabulary. We have the explicit, the general, the nth term. They all mean the same thing. And in this problem we'll have okay. In today's lesson, we're not going to have to come up with this. We're not going to learn any shortcuts to coming up with this. We have to kind of guess and check. Also look at n minus 1 is the exponent here. N minus 1 is just the index of a, telling you which term it is. So if we test this, and we want a2, so we look at a2 as -6, and we put a 2 here. 2 minus 1 is 1. -2 to the 1 is -2 times 3 is -6, so we know it works. And let's just plot a few of these. 1 goes to 3, 2 goes to -6, 3 goes to 12, 4, -24. So we can see that the sequence is getting further and further from 0. And pause the video, try that one. Make sure you do it graphically, numerically, and analytically. Alright, so we have the terms are a sub n. And we need to find the next four terms, so we look for a pattern. And we could say this is plus 2, plus 4, plus 6. Well, that looks like it's a good enough pattern. Plus 2, plus 4, plus 6. And then that will allow us to find the next four terms. Plus 6. So there's 2, 4, 6, 8, 10, 12, 14. And that will give us 21, 31, 43, and 57. So again, we were able to answer the question just with a table. Let's look at recursive form. With recursive form, we always have to have two equations, and one is telling what is the first term, and then we talk about how to get to the next term. So in this we could say, we have to be a little creative here. It'll be the previous term plus 2 times. And here we just have to be creative. We might guess and check, try a few things. But let's check this with, let's say to get to the third term, we're going to use, let's write that out, A3 is going to be the previous. So if this is A3, then this is A2. A3 equals A2 plus 2 times, n is 3, and that'll be 3 plus 2 times 2. And we can check more of them to see that that works. So that's all we need to know for recursive, and this takes some practice to learn how to create this. So if you can't create that on your own, don't worry about it right now. And then we'll go to the general for this problem. The general form is even harder, and I'm just going to write it out. So by using some other characteristics of the sequence, we could come up with this using some formulas. I'm just showing you the difference between recursive and general, but you don't have to come up with these yet. And we have to go up to 13. So we see the progression of the sequence, and we would not connect the points because these are discrete numbers. Alright, so here we have a recursive formula for a sequence, and they want to find the fifth term. So we can just use the table. and they're telling us that A1 is 1, and we have to find the first 4 terms in order to find the 5th term. And that's one of the problems with a recursive formula. You have to find everything in order to get to the end. So let's try this. N is 2, so this will be A2. A2 equals, and I'll write out N is 2, 2 minus 1, N is 2. So we write everything in like that, replace all the N's with what N is. Then this is A1 plus 4 minus 1. 1 plus 4 minus 1 equals 4. So we know that A2 is 4. A3 equals, it'll be A2, it'll be 2 times 3 minus 1. 10 minus 1 is 9. Fourth term, A4 is the previous term. If we want A4, we're going to use A3. A3 is 9. 2 times n, and n is 4. 2 times 4, 8, 17 minus 1, 16. Then we're going to find the 5th term. A5 is, to find the 5th term, we use the 4th term, and the 4th term is 16. 2 times 5 minus 1, 26 minus 1 is 25. So we were able to answer the question. And let's review this vocabulary. We have a recursive form, and that was given. And then we have a general form, which we just have to look for the pattern 1, 4, 9, 16, 25. So here we can just make it up. We see what the pattern is. It's just square whatever n is. And we can also graph that. One, 1, 2, 4, 3, 9. And we don't connect the points. Okay, do the same thing. Pause the video and try this one. All right, A1 is 3, and A2 is going to be negative 2 times A2 minus 1. So if n is 2, I put a 2 there and a 2 there. I copy the negative 2. So negative 2, A, and that's 2 minus 1, which is A1. And A1 is 3. Third term, A3 is negative 2 times A2. A4 is negative 2 times A3. A5 is negative 2 times A4, and A6 is negative 2 times 48. Recursive form is given, and general or nth term or explicit form, they all mean the same thing. In this case, an equals 3 times negative 2 to the n minus 1. And that's a formula for a special type of sequence. We'll learn how to create, there's a formula to create this formula, but you don't have to know it yet. And if we look at the graph, at 1, we'll go to 3. At 2, we go to negative 6. At 3, we go to 12. At 4, go to negative 24. And 5 goes to 48. And 6 goes to negative 96. And we can see the progression. Don't connect the points. This is 1, 4. Then we go to 2, 2, 3, 1, and 4, 1/2. Here's another type of question, and well, they're just giving you a graph instead of a table. So here, let's start with the table. So 1, 4, 2, 1, 1/2. And then we have to think of, we have to identify the pattern, and then we can write out formulas for this. So we could say minus 2, but then minus 2 doesn't work here. So here, let's say this is going to be times 2, not times 2, times 1/2, times 1/2, times 1/2. Then we can make formulas. Say what we start at, and then say how to get to the next term. So we take what we start with, and then multiply by 1/2. Take the previous term times 1/2. And the general formula is better go to the other side. So we have 1, 1, 2, 2, 2, 3, 0, 4, 3, and 5, negative 1. Okay, make a table and try to find a recursive formula. I don't think there's a general formula. Pause the video and try this one. So here we have, we're going to add 1, subtract 2, add 3, subtract 4, and this one we have to be pretty creative on. When we add and subtract, that means we need to do something with this. And this will create alternating positive and negative numbers because negative 1 to an odd power is negative 1, but negative 1 to an even power is positive 1. So this creates alternating signs. So we know we have to do this. A recursive formula always uses the previous term. And look what's happening here. We're going to take the previous number and then add 1, take the previous number and subtract 2. Here we add 1, subtract 2, add 3, subtract 4. We see the 1, 2, 3, 4. All we have to do is get a alternating sign. So we take the previous number plus negative 1 to the n times n. And that's because here we're going to, if we want the second number, we're going to add 1. Let's see if this is going to work. A3 equals A3 minus 1 plus negative 1 to the third times 3. I think that's wrong. We need to change that in. And this is how we write down what we think it is, and then we test it and modify. So here we have A3 is going to be A2 plus negative 1, because negative 1 to the third is negative 1, times 3. So that's not going to work. And what we need to have is this to be a 2. So all we do is we go back to this, and we say that's going to be an n minus 1. So the formula is, just put an n minus 1 in there. I'll rewrite everything. And we just modify the formula until it works. And now that's going to give us the correct number. So that one required some creativity. Okay, that's the end of this lesson.